Hello everyone, this is Dr. N. Srinivas, Associate Professor in the Department of ECE, Lecture3 Institute of Technology and Management, Autonomous Institution. I am here to discuss some important topics in signals and systems. So, this course will be studying in BTech second year, first semester. Here we discuss some elementary signals, discrete time format. So first we discuss sampling. So what is meant by sampling? So discrete time signals are often obtained by sampling continuous time signals, or it is the acquisition of the values of a continuous time signal at discrete points in time. X of t is a continuous time signal. X of n is discrete time signal. We have already known that x of t, it is a function of time, continuous time, where n indicates discrete time. So x is a function of discrete time. So sampling converts a continuous time signal to discrete time signal. We have already discussed this topic in the previous lectures. Now, discrete unit step signal. So the mathematical expression for unit step signal in discrete form. So this is u of n is equal to 1 for n greater than or equal to 0, 0 for n less than or equal to, n less than 0. Here, if you see graphical representation of unit step signal, u of n is shown as a function of n. So n is equal to 1, 2, 3, 4, 5. So the positive integer values, discrete time values there. Because n greater than or equal to 0, it is constant, amplitude is 1. So that's why it is a unit step signal. And it can be also shown as like this: u of n is equal to 1, 1, 1, 1 and so on, because here arrow indicates starting sample. So it is at n is equal to 0. So this indicates n is equal to 0. If this arrow is here, then we can say n is equal to 1. It's starting from, or n is equal to or it is nothing but n is equal to 0. Okay, it is n is equal to 0. Arrow indicates n is equal to 0. Fine. Now if you see unit impulse function in discrete time, so it is denoted as delta of n, that is equal to 1 when n is equal to 0, is equal to 0 when n not equal to 0. Okay, so here n indicates discrete time. So when n is equal to 0, its amplitude is 1. So here sample is there with amplitude is 1. And n not equal to 0, impulse is 0. Means all the points there is no impulse signal. So this is a unit impulse signal in discrete time. The discrete time unit impulse is a function in the ordinary sense, in contrast with the continuous time unit impulse. In continuous time impulse, there is a arrow, but in case of discrete, there is no arrow. It is some dot is there. It has a sampling property. It has no scaling property, that we have already discussed in the previous lectures. So delta of n is equal to delta of an for any non-zero finite integer a, because there is no effect of the scaling factor with discrete time, right? Now if you see one more scaling factor, if you multiply a, okay, so in the RHS side there is no effect on time if it is continuous case, right? Next, discrete time unit impulse train. This is a train of samples. Okay, unit impulse train. There are number of impulse Okay, so here the mathematical expression can be shown as delta of t n is equal to minus infinity infinity summation delta of t minus nt. N is an integer. Okay, so the graphical representation, this is a graphical representation, right? Each and every sample amplitude is 1, right? So we can say it is 1 for all samples amplitude, and when n is equal to 0, 1, 2, you will get 1t, 2t, 3t and 4t shifted version of the impulse signal, and it is a summation and it is having infinite samples. It is and uniformly spaced. What is the gap between two samples? Time t seconds. Okay, so this is a unit impulse train in discrete form. Now if you see discrete time sinusoidal signals, so we already discussed a continuous time case. Now it is a discrete time sinusoidal signals. Okay, a sine 2 pi n by n naught plus theta, that is the mathematical expression for sinusoidal signal, where n is a discrete time. Okay, it is an integer, and naught indicates a period of sequence, discrete period of the wave. Theta indicates phase shifting, a indicates amplitude, n indicates discrete time. 1 by n naught indicates frequency, discrete frequency. Okay, next you can see some sinusoidal signal in discrete form. So positive cycle, negative cycle, positive cycle, negative cycle, positive cycle, negative cycle, and so on, but all are in discrete format. Here also you can see sinusoidal signal. Here also you can see sinusoidal signal. So these are the graphical representation of discrete time sinusoidal signals. Now if you see discrete time exponential signals, x of n is equal to a power n. That is the mathematical expression of exponential signal in discrete form, a power n. But in case of continuous, it is e power at, but here a power n. So where n indicates discrete time, okay, a can be any integer value, right? Now if you see ramp signal in discrete format, discrete time format, so ramp of n is equal to n when n greater than or equal to 0. Ramp of n is equal to 0 when n less than 0, right? If you see the graphical representation, n greater than or equal to 0, it is n. So whatever the value of n, that is n here also. If n is equal to 4, amplitude is equal to 4, because ramp of n is equal to n only, right? So LH side and RH side involving n parameter, right? So when n is equal to 4, amplitude is 4, and when n is equal to 8, amplitude is 8. This is a ramp signal, and the signal is existing only positive side, because n greater than or equal to 0, n is present, and n less than 0, there is no signal. So this is a ramp signal in discrete format. And thank you all for your listening, and thank you for your patience. So if you have any doubt, please contact. This is my mail ID, srinivas.nallagonda@mlritm.ac.in. And thank you all again. Have a nice day.